As we continue in section 2 of chapter 6, rational expressions and functions, but now we're going to add and subtract. Now, the key to all of this, and adding and subtracting, and they are fractions, in order to do so, you must have a denominator that is the same. And a little lesson on that, going back to, I guess, elementary school. If we had, in a sense, two circles, and this is one of these, would be 1/4, and one of these would be 1/2. And you might say, well, you just add them together, the ones, and you might say, is that an equivalent type of thing? And the answer is no, because here you only have 1 out of 4, and then here you have 1 out of 2. In a sense, to make this equivalent, we'd have to change the 1/2 by multiplying it by 1 in the form of 2/2 to make it 2/4. Now with the denominator the same, what you have in the numerator is an equal part. And that's what they're showing here. Here you're having 2 parts out of 7 and 3 parts out of 7. So you can just add the numerators and get a reasonable and honest answer, so to speak. So the rules are, if the denominators are the same, you would just add your numerators. Or in subtraction, if the denominators are the same, you just subtract your numerators. And that's the basic rule. Now it gets a little more complex because we're dealing with these sort of challenging rational expressions. So let's take a look at example 1. And again, we'll use as much as we can of what's there. Here our denominators are the same. So you can put them all over one common denominator, or just do it mentally since the denominators are the same, particularly if this sign is positive. Sometimes you have to be careful if you're subtracting. And they'll give us an example of this later. So that one's pretty straightforward here. Now, one of the cautions they're giving us towards the end here is, could you have canceled something out? And you might say, how about these x's here? Well, this is a term, this is a term. You only can cancel out common factors. And they're showing it there as well. Now, in this case, again, they're right away getting to something a little more complicated. Our denominators are the same, so we're just adding our numerators, which when we do that, we get this. Now, when we get this, we wonder, is this factorable? Now, you should know your denominator is factorable because that's the difference of perfect squares. That is, it can be factored into its conjugates. And as you see here, the top can also be factored. So the way they set it up, you cancel out your common factors and you end up with your answer. Now again, you can't cancel these y's now or the x's because these are now terms. You can only cancel common factors that they're saying that this over this is equal to 1. Anything divided by itself, so long as it's not a 0, is a 1. Now, in example 3, here's where you need to be a little more cautious. And you're subtracting. Now, again, you may want to develop a strategy, so I'll work with you on this one a little bit. So we have a common denominator, which is x plus 3. Now, one of the things you might do when there's a negative here, put this numerator in a parenthesis, make this a positive, and put the negative there. So you end up with something like this, 4x plus 5. And if you can do that mentally, the negative sign in front of the parenthesis, you're just going to reverse both of these signs. So this x will become a negative x, and this 2 will become a positive 2. Now they do show that here. And then you just group like terms, and you end up with this. Again, you can't cancel the x's because they're not a common factor. This is just part of a term here. And if you wanted to qualify your domain, x here cannot be a negative 3. They will do that for a while, and in a sense a review of what we did in the last section. Now, when the denominators are different, as I showed in the initial slide of this chapter or this section, if you have something like 1/6 plus 4/15, you can't add these numerators together because this 1 doesn't signify something that is sort of equivalent to a 1 over on this side. Now this is a 4. So you must divide as we did before. If you're dealing with fourths, you must divide everything so it has a denominator of 4 so that all the parts are equal. Here the parts are not equal. So the first thing you must do is decide what is my common denominator. And you want to get the least common denominator so it keeps the numbers sort of small and it doesn't cause you lots of problems when you have to simplify. Now, back in basic algebra, there was a technique, and let me just show you that technique really quickly here. You divide each of the denominators into their prime factorization. Now, what's the greatest number of times that a 3 is used as a factor in each of the factorizations? Well, the 3, I'm going to write it down here, is used once. So we need a 3 in our final answer. Now we have a 2, we're going to need a 2. That's used once, and the 5 is used once. So 3 times 2 is 6. 6 times 5 is 30. So that's our least common denominator. And this was the technique of getting there. And again, that was covered a long time ago, and you may have forgotten. So now what we're going to do, we have to multiply each of these fractions by a 1. So it doesn't change their value, but a 1 that will allow this 6 to become a 30. So the one we're going to choose is 5 over 5. So this becomes a 30. This becomes now a 5. So now we have this fraction as an equivalent fraction. So the parts of what we're going to deal with are equal. And here we're going to multiply this by a 2 over 2, which is a 1, which makes our denominator a 30, but now our numerator an 8. Now that we have again made an equivalent fraction whose values in the numerator are equal values, we get 13/30 as our answer. And this is what they're showing you down here as well. Now we use this as we go into rational expressions, and they want us to find the least common multiple that will be our least common denominator in a sense. So here they're giving us the strategy. Find the prime factorization of each expression. Form a product that contains each factor the greatest number of times that it occurs in any one prime factorization. Okay, that's what I did in the other slide. So example 4. Find the least common multiple of each pair of polynomials. Well, for our number, we have just doing this mentally a little bit, 3 times 7 and a 3. So our common multiple of the 21 and 3 is actually going to be a 21, because the 3's used once, the 7's used once, so we need the 21. And we have x to the first here, x to the second. So the greatest number of times that x to the second is used is x to the second. So our common denominator then would be 21 x to the second. Now in example B, as we look at it, what we have to do is actually factor that. So let's put our 2 sets of parentheses. And generally the ones they're giving you are not going to be that difficult. And this will be a plus, and this will be a minus. Now here is the difference of perfect squares. This will factor into its conjugates. One is plus and one is minus. Now we have to determine what will be the least common multiple. Well, this is used once in this factorization, so we're going to need one of those. This is used once. Now you might say it's there and there, but in a particular factorization, what's the greatest number of times it's used? Well, just once. So that's why we only need one, and we're going to need one of those. And that's what they have down toward the bottom here. So in a sense, if you were to FOIL this, you'd get x squared minus 16 is a factor, and you need this other one. Okay. Now to add or subtract rational expressions, they must have a common denominator. And since we're dealing with these polynomials, it gets a little bit tedious. And again, if they're asking, we have to list the restrictions on the domain as well. Okay, so a lot of things going on. But we'll start off easy. And we want to develop a strategy for doing them. So we have 2 over 21x plus 5 over 3x squared. Now, my strategy, and what I would suggest you do, is you do something like this. What will be your common denominator? Well, notice we worked on this one already, and we said it was going to be 21x squared. Now, I'm going to use a different color, and I'm going to multiply this by a 1 and this by a 1, but the one I'm going to choose will make my new denominator this. So the one that I'm going to use here, think about it for a moment, what would it be? All right, it's going to be x over x, because now if I multiply this, I get that. And then now my numerator here is 2x. Now what 1 will I multiply this by in order to get my common denominator? If you said 7 over 7, you're right on the ball here. So 5 times 7 is 35, and 7 times this gives me that. So there's my answer. And that was the technique that we used. Now, if I'm going too fast, pause the tape and, study it, write it down. Of course, I'll be doing this in class too. Now again, this is all worked out, but let me help you with it. Well, too much writing, so I'll follow what the book does. So there's the top, there's the bottom. In fact, I think we did this one, didn't we? Or maybe not. Well, I know we did perfect squares there. Okay. So the first thing you do is you take the denominator and factor it. Okay? Now, notice your common denominator here. And before we do that, though, notice they factored this as well, and they're getting a common factor. So they're taking this out. They're factoring this out. And then they end up with this. So now, when you see what you have here, and this gets to be quite long, what will your common denominator be between these two? Well, this is an x plus y, x plus y. Here there's only one x plus y. So you have to multiply this side by a 1 in the form of x plus y over x plus y. Now you have the equivalent fractions, I should say, that you can deal with. So now your common denominator is this, and you just add your numerators. Now you might say, can this factor into something? And the answer is no. So that would be your final answer. So the little trick here, or kind of trickiness is that over here, when you factored this into its conjugates and factored the numerator, you had a common factor that you can cancel out. So you did a little simplification before you went on, and that's a good idea, a good thing. Okay, now we're going to subtract. And each of these problems are a challenge because lots of things will be going on. So again, we have all of this down here, but just look at this. Now, what do we need to do here? Well, first of all, the first thing I would do, so I don't get messed up with all my negative signs, I'm going to make this a positive, and I'm going to put my negative there. That's what I would do. Then I would factor my denominators, which is what they do here. Now notice this is common to both already, so I need that. And then I'm going to need one of these, because that's only found in one place, which I have right there. And I'm going to need one of these, which I now have right there. Now notice they put that negative sign right up there like I did, so that's good. That way you know that this negative will apply to this. Very good. Now, what we have to say, we have our new common denominator. To make this denominator this big one, what does this denominator need? Well, it needs one of these. So I'm going to multiply the 2y plus 1 by that, and that's what they're showing color coding. And then what does this one need to make it this denominator? And you might say it needs this one, y minus 1, which they're doing right here. So now what happens? Well, you're going to need to FOIL this and get that. FOIL this and get that. Don't forget that negative sign is out there. Now the rule is take away the parentheses and then make this, this, and this the opposite sign. That is, in a sense, multiply through by a negative 1. That will change all of these signs. Then what do you do? Again, being very careful. Double check group like terms and put them all over your common denominator. Now this is not factorable, so there's no chance of anything canceling out. That's something you always need to consider. Now, in reflection on just this one example, how many things did you have to do? Well, as you see, all of the steps, all of the work is using all of your techniques of factoring and working with signs and combining like terms. So this is something where you're writing your example out in a clear, distinct way. Double checking your work is going to be very important to get the right answer. And these are a challenge. It may take 10 minutes to do just this one problem. Okay. Example 8. Now at least we have sort of an easy one. Maybe I could work this one out for you from scratch. Now it looks like we have an 8a and an 8a, except this one's the opposite sign. So my denominator is actually going to be 8a. Now how do I get rid of this negative sign? Well, the answer is just move it up there. Make it positive there. Make this the negative. So now we have 3 minus 1 is going to give me a 2. And then can you cancel? Yes, this becomes a 1. This becomes a 4. So my answer is 1 over 4a. So compared to the previous one, this one was sort of an easy one, but they're showing this little technique here to help you change signs. All right. Now, we're going to use that here a little bit too. So let me do this one as well. Now, as you look at your denominators here, x and 2y, x and 2y, but the signs are the opposite. So my denominator eventually is going to be, let's make it x minus 2y. Now, there are different ways to do it. I'll use this one. Now, in order to do this one, to get it to be this, I had to factor out a negative 1. A negative 1 will reverse the signs, and I can switch the order of these and make that x minus 2y. I'm taking a negative 1 out of this, and that makes this negative and this positive, and then using the commutative principle to switch them around. I'll have a little extra mark right there. We go. Now, notice I could go like this, make this a plus, put the negative up there that we did before. Now, an interesting thing happens. I have a negative divided by a negative. So what's going to happen here? This will become a positive now. So I've changed this whole thing around just by fiddling with this denominator. So now my new numerator is going to be 5x plus 3y minus 7. And that is my answer. Okay? And the book shows it a little different way. I kind of like my way, but that's what we got. And they're showing you the way I did it as well. Okay, number 10. Now here, I'm not going to, all the work is shown here, and it is quite tedious, but let me go through a couple of steps here. As I see the tape is running long. What will my common denominator be? Well, notice these are the difference of perfect squares, which will factor into their conjugates. X plus 2, x minus 2. Now here I have an x plus 2, that's this one, And here I have the signs that are switched around. So again, if I take out a negative out of here, this will become a negative x minus 2, which is this other one. And I can put this negative sign up here by the 5. They're going to do that somewhere, and I see they've done it right down there. Okay? So my common denominators then are these, and I don't have to, well, I have to modify these two by multiplying this one by this, which is x plus 2, and this one by an x minus 2, which they're doing over here. So now my common denominator is this, and I end up with 2x. Now notice that's a minus 5, minus 5x minus 10. And here I'm going to make this a plus. I should have done that earlier. Put the minus there. That's good. So this then becomes a negative x and a positive 2. So now I have done it. Again, they do it a long way, showing every little step. What I've tried to show you maybe is a little shorter way, but a lot of stuff is going on. And in fact, this goes on to the next page too. So there's what we had. As you group like terms, you get this. Notice now x plus 2 will cancel out. So you are left then with either this, with the negative at the 4, or the negative at the division bar. And you're giving qualifications for your denominator here, for your domain, that x is any real number, but x cannot be a negative 2 or a 2. Wow. And they're showing you some graphing that we are not going to be using. And that wraps it up. Wow, 33 minutes, lots of stuff going on, and you will have practice and then your quiz me. And good luck. Looking at some of these, again, some of them start off easy, but when you get into trinomials in the denominator, and you have to figure out what's your common denominator, then modify your numerator so you have an equivalent fraction that you can add or subtract.